We are back and working on chapter 11. So this is the second video in chapter 11 on fluids at rest. We want to talk about the apparent weight. So we've talked about Archimedes' principle, how the an object that's submerged in a fluid, so a gas or a liquid, will be supported or buoyed up by something called the buoyant force. And we've looked at the displacement with the little graphic and the overflow, and we know that there's a difference between when objects float and when objects sink. So if you have an object and it's in a fluid, its weight will be different from its weight in a vacuum. So the apparent weight of an object is measured when it's immersed or partially immersed in some kind of a fluid, so a gas or a liquid. It'll be the weight of the object in air will equal, the apparent weight will be the weight of the object in air minus the buoyant force. Well, we almost never really want to use this form of the equation. We're going to convert weights to masses, and let's look at the apparent mass. So the apparent mass is equal to the mass of the object in air minus the mass of the displaced fluid. So APP is my abbreviation for apparent, OBJ is my abbreviation for object, and fluid is just fluid. And these little abbreviations are meant to be subscripts, so below the line. So for a floater, the mass of the object is equal to the mass of the displaced fluid, so their apparent mass is going to be 0. When you float, you are weightless. Whether it's in air or in space, or whether it's in the pool. So let's look at an example where we try to calculate the apparent mass of a 10-gram lead weight. Lead has a specific gravity of 13, and we're going to put it in alcohol that has a specific gravity of 0.7. So we know the mass of the lead is 10 grams. Again, lead should be a subscript. The specific gravity of lead is 13. The specific gravity of alcohol is 0.7. We know it is a sinker. And we know that the density of water is 1 gram per cubic centimeter, which is the same thing as the 1,000 kilograms per cubic meter. We want to find the apparent mass. That's what we're looking for. Our formulas are density is equal to mass divided by volume, and that apparent mass is the mass of the object minus the mass of the displaced fluid. We also know that floaters displace their own mass and sinkers displace their own volume. So if you're a floater, the mass of the object equals the mass of the displaced fluid. For a sinker, the volume of the object equals the volume of the displaced fluid. And we know that specific gravity is equal to density divided by the density of water. So the first thing we want to do is draw a table and fill in the numbers we know. We know the mass of lead, and we know some specific gravities. So the table will be for the object and the fluid it's in. So our object is the lead weight and the fluid is alcohol. So we have a column for the items, so the object, which is the lead, and the fluid, which is the alcohol. Because they gave us specific gravities, we have a column for that, and I've gone ahead and put in the numbers, the 13 and the 0.7. And then we are going to need density and mass and volume to use this first formula, so we put those in the table, and the only one of those we know is the mass of the lead weight is 10 grams. Normally, I leave the units exactly the way they're given in a problem unless they tell me otherwise, because normally it's easier. So we have drawn our table and we're filling in. Now I'm going to show you the table multiple places in the problem. You only have to draw it in once, but I didn't want to have to keep scrolling back to it and inserting things. So, all right. So what do? We look at the table. And we need, of density, mass, and volume, we need more of at least one of these. So because you know specific gravity, you can convert specific gravity into density. In some problems, you're not going to have to mess with specific gravity. They'll give you the densities, and you can just leave out this column on specific gravity. But they've given us the specific gravities. We need to find the densities. So to find the densities, we remember that specific gravity is density divided by the density of water, and we know the density of water. So we can do that. We're going to change our specific gravities into densities. Specific gravity is density divided by the density of water. We'll start out with lead. So 13 is the specific gravity of lead. We want to solve for its density. Because they gave us masses in grams, we're going to use 1 gram per cubic centimeter for the density of water. And when we cross multiply, we find that the density of water is 13 grams per cubic centimeter, and we will put that in the table. You'll notice I didn't even bother to write down the calculation for alcohol, because one of the beauties of using CGS units is that if you know the specific gravity, that's the same value as the density in grams per cubic centimeter. So whatever number we've got, that's the same as the density in grams per cubic centimeter. I really didn't have to calculate it. I could have just written it down. Now, if we had wanted it in kilograms per cubic meter, you probably would need to go ahead and convert, because most people mess that up. All right, now what? We look at the table. So we've got this line, the lead line, we know everything except the volume, so we should find the volume. Pick the line that has the most things in it and see what you can do with it. So we're going to find the volume. So solve for the volume of lead. Density is mass divided by volume. We know the density, it's 13 grams per cubic centimeter. We know the mass, it's 10 grams. We can solve for the volume. So the volume ends up being 0.769 cubic centimeters, and we put it in the table. And again, you don't need to copy the table over every time. I just did it for convenience sake. You should probably draw your table once and just fill in as you solve for things. Now what? Look at that table. In this table, either the masses will be the same or the volumes will be the same. The masses are the same if you have a floater. Floaters displace their own mass. If you have a sinker, the volumes are the same. So how do we decide if it's a floater or a sinker? Well, an object that has a density greater than the density of water will sink. I'm sorry, greater than the density of the fluid it's in. Since we're not in water, water wouldn't help us very much. So an object that has a density larger than the density of the liquid it's in will sink. One that has a density smaller than the liquid it's in will float. So our object is lead. Its density is 13 grams per cubic centimeter. We are putting it in alcohol, which is only 0.7 grams per cubic centimeter. My object is going to float. So it is a floater. Floaters displace their own volume. That means the volume of the lead and the volume of the alcohol are the exact same. Because it's a floater. I'm sorry, because it's a sinker. What was I saying? Because it's a sinker. I didn't say that wrong too many times. Floaters displace their own mass, sinkers displace their own volume. Lead is a sinker, lead is going to have the same volume in as the object as the displaced fluid will. Now what? Look at the table. We've only got one missing thing. Oh dear, this should not be a P, this should be a row. I need to fix it. It got changed. I am sorry. Let's see if I can find my rows. Oh, where did it go? Where did it go? I just now noticed it. It's probably been wrong in the other tables too. What happened is the computer capitalized it. When I wasn't looking, it's a rho, not a P. This is density. If you wanted to write the words, you certainly could. So the one thing we don't know is the mass. Density is mass divided by volume. So 0.7 grams per cubic centimeter is equal to M divided by 0.769 cubic centimeters. Cross multiply and we get the mass. Well, that helps, but that doesn't answer the question. The question is, what is the the apparent mass? What is the apparent mass? Well, the apparent mass formula is the apparent mass is equal to the mass of the object in air minus the mass of the displaced fluid. And this will almost always in these problems be the very first formula you use or the very last one. It's almost always the very first or the very last. So for this one, it's the very last. Apparent mass is going to be the mass of the object in air. That would be the 10 grams minus the mass of the displaced fluid. So that's the mass of the alcohol. And that would give us 9.462 grams. 9.462 grams. That's our answer. The table is really helpful if you will just let it lead you along. Do your study guide problems. Actually, the best thing is to start with this example and see if you can repeat it. Let's look at these two quick examples. We have 3 containers. In the top example, the objects are the same, and I want to know which liquid is the most dense. Well, the denser the liquid, the higher you'll float. People who normally float can almost always, normally sink at the beach or in the pool almost always can float in the Great Salt Lake or certainly the Dead Sea, because both of those bodies of water have really high salt content. So the water is very dense and it pushes you up. So in this diagram, container in the middle, number B, is the one that the liquid is the most dense because the object is floating the highest. In the bottom diagram, all 3 liquids are the same. We want to know which object is the most dense. Well, of course, that would be the one that sits the lowest. So container A, that object is the most dense because it's sitting the lowest. B is the least dense because it's floating the highest. And C is in the middle. And that stops the video.